Now, I was on Twitter recently and somebody asked me about this adapter that I have here, and in particular whether it was 3000 milliwatts, which would be 3 watts of power. And I had one of these, I've had one of these for quite some time, but I've never removed it from the box. I think I only paid about £8 or £10 for this, free shipping. And I told him that you could probably easily knock a zero off that and it would be closer to 300 milliwatts of power, which is about standard for these adapters. Now, I've taken it out of the box since, and it probably is around 300 milliwatts of power, maybe 400 milliwatts, but certainly nowhere near the claimed power output of this. But I thought what would make a really interesting video is if I make a jig, an antenna setup just for this, taking advantage of the two SMA connections on this. So what I thought we'd do is make a double Yagi setup for this. Not overpowered Yagis, but probably something like 4 or 5 element Yagi antennas, and have it where, you know, we've got this adapter in place, but you could also stick a alpha card or some other similar card to this in place instead of one of these cheaper Chinese ones, but build a jig around it and also show you a new driven element for a Yagi that I've come across quite recently. Show you how to build that, which is another driven element that I'm quite impressed with because it has a built-in balun as well. So I've already done some cutting out for this build then, and I've got some of this angle. It's 12mm by 12mm aluminium angle, and I've cut it already to fit the adapter, because I'm going to house the adapter in this and have some Velcro on there so we can attach this adapter and remove it if needs be. But this angle is going to hold it securely in there, and as I said, I want two Yagis to connect to this, and I thought about this, and you know, we could connect them where they're rigid and you can't move them, which is not really taking the advantage of the Yagi's beam width, the angle of the angle of the beam that the Yagi produces, which is about 45 degrees for a 4 or 5 parasitic element Yagi. And it'd be really nice if we have this like a desktop adapter, and you could alter these so you could move them further apart, say like that, and then you can extend that angle of the beam width for this antenna setup. And of course, if you just want to concentrate on the one access point, you could bring them together and send all your energy in that direction. Or if you want to scan for multiple access points to find out where the best one is, you can just open it up and then take advantage of having virtually 180 degree angle beam width, which you know, I don't think there's a single antenna out there, that directional antenna, that can produce that. So it'd be a really handy little setup. Now I've got some aluminium sheet here. It's 1mm thick, and we're going to be using this as the base to support everything. So I've got my little box that I've already cut out here, and I've got the two box tubing that is going to be the two beams for the two Yagis, and I've put a measurement at either side of there, so that's the minimum width that I need this to be. And as I said, I'm thinking of being able to open these two Yagis up like so, possibly have them anchored in here, and you know, maybe even riveted on, but just held firm enough that they won't just slip all over the place. And I'm kind of thinking that that's about where the maximum is going to be, where I'm going to extend them fully, and then of course we can move them back in if needs be. So that's the kind of area that I'm looking at for the base. So I think I've got my basic shape here, and you can move these out like so. But what I'm going to do, because we don't need this sharp edge, I'm just going to get my roll of masking tape and just round the edges off, and then I'm going to cut this out, and that's going to be my base. Pretty simple, really. Now that I've got the base cut out, I'm just arranging all my pieces on here just to see how they all fit together. I ended up rounding these off a little bit more than I originally intended. I think it looks a little bit neater like that. But I do think that this is going to work out really well. I am going to have to put some kind of stoppers on the ends of here. I'll probably use some of this angle stuff again, and just have something on there so we can't swing these out too far. So I've riveted everything together on here, and I've also got a piece of aluminium bar at the bottom. It's 3mm thick, so it adds a little bit of weight to this, so it'll stabilize it when we get the Yagis protruding out. It'll balance it out a lot better. And I've also tapped out the threads for a tripod mount in here. Now I want to move on to making the Yagis for this little rig, and I want to spend the majority of the time showing you how to make the driven element, because I haven't shown this particular driven element on this channel previously, but I have shown you the basic dimensions of this Yagi. It's the same as the one I've been playing around with recently. Basically all the parasitic elements are the same length, and then we have the director at the back here. The parasitic elements are spaced out at 30mm, and that's in the middle of the parasitic elements, so 30mm, 30mm, 30mm. The back reflector here, the director, that's spaced out at exactly 60mm, so it's double the parasitic elements. It's that's why I love this particular kind of Yagi. It's pretty simple to make. Each one of the parasitic elements are exactly 50mm long on this design, and the back director, the reflector here at the back, that's 70mm long. So really simple measurements. Now as for this box tubing, it's 12.8mm wide. It's really nice stuff. I've used this previously in videos, and the diameter of the aluminium tubing that we're using is just over 6mm, 6.2mm, but I think the cell this has 6mm diameter, and that's the same diameter for the back reflector as well, just to keep it nice and simple. And the length of the boom for this Yagi is 29.5mm long, just under 300mm, and that's just because of how I'm going to mount this. You can make it a little bit shorter if you want to. So the first thing I'm going to do then is connect all the elements up to the boom, and I'm just going to rivet those in place. Now I forgot to mention, I also add a little bit of super glue underneath each element just before I rivet it in place, and then I also use a set square just to make sure that I've got it lined up nice and straight. So this is the driven element that we're going to use with this Yagi, and I really do like this driven element purely because it has a built-in balun and seems to work really well. Now you're going to need some kind of tubing, copper tubing preferably, because it's easy to work with, it's nice and soft. This tube here is 5mm in diameter, 4.9mm, just a tad under 5mm, and you are able to bend this without any kind of bending tool reasonably well, and this was a prototype, and this one works exceptionally well, and this is the one that's led me to build this one that you're going to see today. I did try this with just coax on its own, but this one doesn't work too well, and I think the reason why is because it doesn't have any balun. Basically the tube acts like a balun, and you'll see when we build that, why that is. This one doesn't work too well, as I've said, but it does show you how you need to connect up to this. You can see I've got ground here and ground here. That's the main signal coming in there, and then over the top here where it's connected up, so it forms a loop. But as I said, this doesn't work too well. You're going to need some tubing. Now the tubing that I've decided to use for this build is 6mm, so a little bit wider than this one, and I did bend this with a bending tool. You can pick those up pretty cheap off eBay, and I'm looking for one that will also bend slightly smaller tubing. The reason I'm not using the smaller tubing for this build is because this won't bend with that particular bending tool. But you can see here we've got the bending there, but we need to bend it a little more, and I'll show you what we're going to do to bend this a little bit more. Now to bend it a little bit more, I wanted to bend it without forming any kinks in this. So what I decided to do is cut into it like I have on this one. I think it looks rather neat when you do that, but I'm going to take these over to the bandsaw, put 3 cuts in each one, and that will be much easier to bend it into the shape that we need. You can see it's just not quite bent enough, but that's what we're going to have to do. So let me do the cuts first, and then I'll show you how to connect all this up. Now I've got my cuts onto my elements here, so it's going to be much easier to bend, but don't bend it yet. The first time I did this, I bent it, and then it makes it so much more difficult to get the coax fed into this. But each one of these are measured off at 54mm long. Now each one needs to be 54mm long for 2.4 gigahertz, but I've added an extra 2mm to the ends of these, so these are now 56mm long. And the reason I've done that is because I'm going to mount it into some of the box tubing that we've used to make the boom. This is 20mm long, and I've drilled the holes through here right at one end, because we're going to need to go in there with a soldering iron, and also on this end we're going to drill a hole through to insert a bolt to fix this to the boom. But the reason I've added those extra 2mm on is because that's going to be inserted into here, so we need that extra 2mm. So from here right to the end of here, that's 54mm. So I'm about to solder this up, and I want to show you how you solder this up, because if you don't do it like this, it won't work. Now at this end here, this is the end that's going to be fitted into this piece of box tubing here. I'm going to be putting solder around here and soldering it up to the beginning of the tube there. Now on this end, I'm going to be putting some heat shrink tubing around there, so the outer braid cannot make contact at the top, so it's just runs all the way through here, but it's not made contact at the top. Of course, this is connected down here to the outer braid, and that also runs all the way up here, and that is your balun. If you don't do it like that, then you won't have a balun, and that's the problem that is wrong with this one. If I was to put some tubing over this, soldered it up to the beginning down here, and then insulated this so it couldn't make contact, this would work perfectly. But because it hasn't got that, you know, like a double grounding, if you like, on this side, it doesn't work as the driven element. Well, it doesn't work very well because it doesn't have that balun effect. So that's the difference with this one. It's going to be soldered here down at the bottom, and this here is going to be isolated with a little bit of heat shrink tubing. Now you have to get quite a bit of heat into this because the copper will suck it away, but you also have to be careful not to melt the coax. Now I also need to prepare the second one. There's no coax that runs through this, but we're going to have to solder at the top here and at the bottom here, because we're going to have to connect through there. Just this signal wire here will be soldered onto there like so. If I show you this one, you can see it much more clearly. Now you can just put solder on the end of these, but the problem is when you come to solder your connecting coax on, you haven't got a lot of room inside here, and you also have to have your soldering iron temperature turned right up, because this will act as a heat sink. Now if you block each end with a little bit of copper tape and solder the copper tape onto there, it acts like a little solder pad. The solder that's on the tape will flow a lot easier than the solder directly connected to the copper pipe. Just makes it a little bit easier, and of course you don't have to use as much solder then to block up each hole. Now I'm going to solder this part of the signal wire over onto here then, but also remember you need to cover this to protect it with something. So I've slipped some heat shrink tubing onto this side, and now, because I've got all parts of this pre-soldered, I'm just going to hold it with my tweezers here and just apply some heat to fix that into position. Now I'll just shrink the heat shrink tubing over that. Now I'm going to try and show the soldering process on the camera, but it's really difficult for me to do this. I'm at a really weird angle. I mean, there's not a lot of space to work in there even when I'm not trying to film it, but you can see how I've prepared the coax, and basically it's going to sit inside there. The two outer parts soldered directly on there, and then got to come in with the soldering iron and solder this signal wire up. So I'm going to give this a go. So at last we seem to have a good connection on that side. It took me a few goes, but now I'm going to manipulate all the other parts in place. I'm going to solder the other ground wire over onto this side next, and then finally this signal wire in the middle. And it was just too difficult for me to get it on camera. There's just not a lot of room to maneuver in there, and I needed to bring the work closer to my eye as well. But hopefully you can see there all those 3 points soldered in, the two grounds and that signal wire. So next I've got one of these little square plugs. I have cut these down. These are a little bit longer. There's no need for have it that long. I'm going to plug this end, and then I'm going to put epoxy down in there to seal everything up, and then no matter what happens, there's definitely no risk of shorting anything out in there because it'll all be sealed up in the epoxy. And just before the epoxy sets, I've got another one of those end pieces, and I've cut away so it's quite flush, drilled a hole through it so the coax can go through, and then I'm just going to insert that on the end of there. Now the driven element is held in place with this M4 screw going all the way through here, and I tapped out directly onto the boom itself, so it's in there quite tight. Also just a little bit of epoxy on there as well, just to stop it from sliding around. But to finish it off, I'm just putting these end caps on here. Now you don't have to do this, but you can pick these up off eBay pretty cheaply. You can get a bag of 50 for only a few pounds, and it does finish it off quite nicely. Now for a couple of things that I did off camera. I want to get this action where I can move these Yagis in and out, and in order to do that I had to mount them about 3-4 millimeters away from this side, otherwise this edge here would catch on this here, so it wouldn't be able to move out. So I had to mount it a few millimeters out there, and I filled in the space here just with some cork, and I sprayed it black so it fits in with the build, so it, you know, it sits flush on there. If I didn't do that, it would catch there on the bottom. I also forgot to cut out there so we can connect the USB to the wireless adapter. But I think it's time for a test now, so I'm going to fit the adapter. I'm going to use some Velcro in there and remove this from its packaging. I've just realised I haven't even tested this yet, so hopefully, fingers crossed, it will work. So let's give this a quick scan then. I haven't tried this yet. So again, it's here in the lab, not in the open air. It's got a few brick walls to go through, but it's looking pretty good so far. All those access points are really nice signals. It's level 14. So in the end we picked up 20 access points. A few of them have dropped out since, but pretty impressive for the two Yagis. I'm not sure how well the wireless adapter does in this kind of test. I haven't tested it against anything else, but I'm pretty happy with that. So to summarise then, I've really enjoyed building this over the last couple of days. I do think it's an extremely practical rig. I mean, it's not overly big, and you could easily put this into a backpack. And for something you want to take away with you and you know, just scan for open networks, allowing this to increase the beam width so you can find them by moving these in and out, I think you know, is a really nice idea. Yes, we picked up quite a few access points here in the lab, and it does have to go through a number of brick walls to get that signal out there, but this cheap eBay adapter is a bit of an unknown. I haven't tried it with anything else. It's certainly not 3000 milliwatts as advertised, but I think in a future video I've ordered the alpha adapter, the dual channel adapter. It's 2.4 gigahertz and 5 gigahertz, and it's got 4 outputs, 2 for the 5 and 2 for the 2.4 gigahertz. So we'll give it a test with that when I get it in the lab. But as it is with this cheap adapter, I think it's performing really well. As for the Yagis with 4 parasitic elements, they'll be working at about 9, maybe 10 dB of gain each, so they're not overly powerful. But if you look back at a video I did last year when I did the bespoke Yagi antenna, when I made little add-ons where you could extend it out, because this design, you know, it's all the same measurement between the parasitic elements, and they're the same width, so it's really easy to extend this out and increase the gain. But yeah, as I said, as a build, I've really enjoyed this one. So if you do have any comments or questions, drop them below, and if you did enjoy the video, please give it a thumbs up. And if you want to support this channel and you know, keep bringing content here on YouTube, please consider joining the Patreon. But if you did enjoy the video, give it a thumbs up, as I said, and hopefully you'll join me on the next one.